Hi, my name is Chad Rose. I'm from the Mechanical Engineering Department at Auburn University. I'm going to present about our CUTC new initiative project, Human-Robot Interactions in Transportation. So a little bit about me. My background is in physical human-robot interaction for things such as assistive or rehabilitative exoskeletons and haptic communication to improve the performance of teleoperated, semi-autonomous, or autonomous systems. So my previous work in education has been looking at how can I use haptics or anything dealing with the sense of touch to improve undergraduate laboratory experiments, specifically in areas such as system dynamics and controls. So I think there's a really interesting opportunity for using haptics in the future of transportation, either directly implementing haptics for things like drive-by-wire or managing complex cyber-physical systems, or to use haptics as a teaching tool for these outreach or educational activities. So to kind of the motivation for our project was that I'm working with a team that has over 10 years of experience with after-school and summer programs, and they found that hands-on activities are the most engaging and the most effective at encouraging students to pursue STEM education and eventually careers. And so I typically think about this through Kolb's experiential learning cycle, which basically says that the best way to learn is to have a concrete experiment, some reflection, followed by active experimentation. I think the only way to do that with some of the, I'll say, more theoretical or abstract concepts we typically find in STEM, engineering, and obviously in the future of transportation is trying to create this physical experience. And so I think hands-on is a fantastic way to do that. And so the other thing that we're looking to do is to create a tool or a set of tools that will allow us to do not only standalone activities, because sometimes you only have a little bit of time to spend with a student, maybe in a field trip or a show and tell type event, but also to create a set of tools that is capable of sustaining student interest and activities over multiple days, or through a summer program or a multiple week after school program. So also I think it's really interesting as kind of a newcomer to CUTC. I think that the mechanical engineering and robotics side haven't seen as much attention, and so I think this is a really nice chance for me to kind of get involved with this group, and for this group to kind of see the more robotic side of things. So I typically think that some of these concepts that we're going to try to teach are kind of these abstract things like a sinusoidal wave and these functions over time, and how can we modify this relationship between variables to get some desired output or some desired behavior. And this is really abstract, especially for some of the middle school students we're looking to engage. And so what's been done is, sometimes it's more easy if we can show a schematic of the type of system that we might be working on. But even still, these schematics aren't the same as touching or doing. And so there's been a lot of work on developing these haptic interfaces, such as the OmniMagic shown here, where these can render virtual walls, virtual objects, virtual springs and stiffnesses. It's really fantastic, but the challenge is these devices cost thousands of dollars, and sometimes they can be out of reach even for researchers like myself. So they're not well suited for working in after-school programs. So to this end, there's been a really vibrant, exciting group working on low-cost haptics. So here's the HAP kit from Stanford, and the whole goal of this is how can we put low-cost haptics in the hands of as many people as possible. And so these devices are classically called a haptic paddle. I have a sample one here. It's called a paddle because of the shape of this kind of the end effector. And so the haptic paddle is a single degree of freedom. So it has basically a microcontroller, a handle. Sometimes folks add some sensors, but basically, and then a DC motor, and that's it. And so this DC motor, through the microcontroller, is kind of the control you might design and implement on the microcontroller. You can render virtual environments in this 1 degree of freedom. So bumps, virtual walls, ridges, that sort of thing. So the idea is to create hands-on learning about these concepts through a kinesthetic haptic system. So not just things like vibration, but actual motion. And so these have been developed for the past almost 25 years. And so the kind of the seminal work is Alison Okamura's at Stanford. And I think some of the most recent stuff that has been done is in a partnership with her and Melissa Orta Martinez, one of her former students, is now at Carnegie Mellon, and they developed the HAP kit. And so they've I think, kicked off this community, and in response, several other groups, including my previous institution, have developed haptic paddles of their own, each with their own unique performance and unique curriculum and kind of their own flair to address the specific educational needs of their program. And so, as I said, it's an interactive single degree of freedom, so just can only move one way. But within that single degree of freedom, there's a really nice opportunity for presenting a wide range of haptic environments and as a springboard to things all the way up to, I'd say, some really interesting nonlinear phenomena for our undergraduates. So the kind of previous work studying with these panels has shown that this is beneficial to a wide range of curricula, especially at the undergraduate level, but also for things like MOOCs and other kind of more outreach-focused activities. So the project that we'll be working on over the next year, the first goal is we want to create an open source design and open source curriculum, kind of following the ethos of the haptic paddle kind of maker community. We want to be able to contribute to that with our own kind of transportation or future of transportation flair. So our next goal is we want this kit to be at least, or at no more than $100. Our hope is to drive this cost as low as possible to make this approachable to as many different schools as can be done. But we're setting our goal for at most $100 total kit cost. And so the thesis that we're going for is we want to create a hands-on experience of the fundamentals of the future of transportation. And so our goal is that maybe the more abstract kind of fundamentals behind the future of transportation, where this is some important math or some dynamic systems that we might need to explain, helping students make the jump from this mathematics to, I would think, the really exciting, motivating, interesting things like connected vehicles. We want to bridge this gap better with a hands-on, haptic experience. And last, we're going to validate this approach with a pilot study, and of course, we'll make all this available to other UTCs. So to walk you through kind of the steps of our project, the first thing we're going to do is we're going to design a haptic paddle with a transportation focus. So I'm going to be working with the College of Education and Dr. Rylett to modify, alter, or somehow kind of build upon the existing haptic paddle design language to create one that's specific for the needs of the transportation community. We're going to build some kits for some outreach activities. Then we're going to develop a curriculum to match the different levels of student coursework that we're expecting to see, ranging from middle school up to high school. And then we're going to conduct a pilot workshop with some local educators. We're going to show them the paddles. We're going to let them experience it. We're going to have them walk through the curriculum themselves. And then the main output of this workshop is going to be ways that we can improve either the hardware or the curriculum, and hopefully both. So then our plan will be to build more of these kits, these new updated kits, and implement them in classroom or after school environment, and donate the kits to these teachers and schools in exchange for them helping us develop it. Then with the results of this in classroom or in school example study, we're going to do one last hardware curriculum tweak if there's anything we notice, and then we plan on disseminating the final hardware and curriculum to CUTC and broadly in the haptics for education community. So the programs we're targeting are in Alabama and Nebraska. So we are partnered with some summer programs for Native American high school students. We have local after-school programs for a middle school, and our target goal is to be at K through 12 schools that have a high federal school lunch waiver eligibility. And so the other goal we have is to expand what will probably be these kind of single pilot study cases, expand that curriculum that will, in a 1 hour type setting, expand that to be amenable to multi-hour, multi-day experience for these students. And so lastly, our project, we're going to emphasize transferability to the other UTCs. Of course, we're going to disseminate the design of the curriculum and the results of our study and any advice we might have. We plan to post our lesson plans as well as our CAD and bill of materials and assembly guides to websites such as the link I've provided here. And in general, we want to bring this haptic paddle kind of community to the CUTC. And so we're open to working with any other university or any other group that's interested in developing, modifying, changing, using extending the haptic paddles in any way. It's always fun to get to work with other people, other new ideas. So that's our goal, is to create a tool that as many people as possible can use. So to conclude, the goal of my project is to create a hands-on experience of the future of transportation for a wide range of students. I'd like to thank the new initiative project sponsorship from CUTC, without which we couldn't be doing this. I'd like to thank my collaborator, Larry Rowlett, the Autry director and professor of Samuel Ginn College of Engineering. And I'd like to thank my students in my wearable and biorobotics, or the Weber lab, who will be helping me make this happen. So thank you, everybody, and thanks for your time. And I'm looking forward to sharing some haptic paddle design and curriculum soon. Thanks.